Hello and welcome to Emerald Hill Skies. My name's Doug and we're observing tonight from the outskirts of Louisville, Kentucky. On the left-hand side of your screen, you can see the Rosetta Nebula just starting to dip its way down into these treetops. These little greenish colored things are the tops of leaves. But if you look carefully, among the tops of these trees, you'll see the beginnings of the Rosetta Nebula starting to come in. The Rosetta Nebula is Caldwell 49, one of the most beautiful deep sky objects when it's not floating into the trees. Now, if we dial up the mids here, you'll see the shape of this object a little more as it's forming up there. There you see a little bit more of the tops of it, don't you? If you look up toward the top of this picture, and you can imagine kind of the rest of the object formulating in those treetops. We're hovering at about 19 degrees above the horizon, but we also have about 19 degrees of trees tonight. But if we leave it dialed up pretty high there, you can see this is some of the hydrogen alpha cloud stardust that's being lit up. Some of the hydrogen gas is being lit up by this bright cluster here in the center. You can see over in our planetarium software, it's called Starry Night Pro Plus. We use the Plus edition. Along the outside of this Rosetta Nebula formation, you can see several different deep sky objects. Among them are NGC 2238 and NGC 2239, NGC 2246 and NGC 2237. These are all different star clusters and also some of the dark nebulae. Now, this is particularly hard to see, but if you strain, I mean, you'll have to get your eyes really close to the screen here. I'm going to see if we can dial up those mids a little bit more, and you'll see the treetops dialing up as well. But look at some of these dark paths here in the middle of those treetops and the reddish tint that you have there in those nebulae. Look at this these dark lanes. It almost looks like rivers of darkness in the middle of that red rosette pattern. Those are dark nebulae, and they're caused by soot, none other than just soot getting in the way of the kind of the neon lights that are emanating from the cloud of dust. And if you look over here to the right, you can see those dark lanes in our planetarium software and then see them right here in the real picture descending down into the treetops. Up here, you can see a little bit more of the unfettered image. And if we come over here, this is what the Rosetta Nebula would look like. We thought we'd come back to this image for tonight's session because we kind of ended with it the last time, and I really felt bad that we didn't get to enjoy the Rosetta Nebula and all of its beauty. Unfortunately, even though we're doing a little better tonight, less moonlight, maybe a little less light pollution, but most of all, we have tree pollution in this case. But on the right here in the planetarium software, that is actually our image that we've pasted onto the night sky of Starry Night Pro Plus. I shared the other night, if you were here with us, then you know that Starry Night Pro Plus comes strangely absent of the Rosetta Nebula. And I'm not sure why it's that way. I was just checking the audio there on the live stream. Not sure why it's that way. Al, thanks a lot for the encouragement. In the middle of all those trees, you're saying good work. It's really pulling the object out of the treetops, isn't it? But here on the right, this is one of our pictures that we've pasted on Starry Night Pro. Now, if you want, we can show you. If we look up the, see, this will be, if we look up images here and we turn off user images. I don't know if you can make it, you can see on the right. No, probably can't see here. The print's probably too fine, but I'm going to switch the little switch that turns off user images. And you can see that's the way Starry Night Pro Plus comes from the manufacturer, the folks at Simulation Curriculum. So that Rosetta Nebula didn't quite pop enough for us. So fortunately, Starry Night Pro lets you take your own images and match them with the stars in your own images. So you can line up the stars pretty well if you shrink it and expand it and rotate it around. You can line it up pretty well with the stars. And sure enough, that's the image that we took when the Rosetta Nebula was a lot higher in the sky, and we were able to gather that. So let's take one last look at this treetop view of the Rosetta Nebula. And you know, that's 10 minutes of imaging, but we're getting a lot of nice images of the treetops there too. So can't really sort out the trees from the nebula very much. Let's get our list back where we were a while ago. We'll get our lists back in our view here and go to Caldwell Working. That's the list that we're using to work through. And you can see now we'll sort it by altitude, and there's Caldwell 49, and we've got it up here. We'll do a quick little log entry on this, and see, we need to do an observing session though. Let's go ahead and delete that log entry, and let's start an observing session here. So we're going to go to sessions, and this will be session 64. So we'll go new and do, this is the beginning of 0064, Caldwell part 7. And we're going to say that this will last, who knows how long we'll stay, but it'll be sometime in the middle of the night. And we're happy that there's less moonlight tonight. How about that? Less moonlight. So we have to increase our next date there. Now we can say, let's delete this one while we're here, because that one started up a while ago since we hadn't named it. Called it Untitled Session. So now we're on, call that session 64. That need to be session 65. Change that name, make that session 65 since we started. Okay, so session 65. So now we can do a new log entry here, and it shows session 65 for us. And we're using the Caldwell list for our list. And we're also going to say here that we're using this RASA 11 with the ZWO ASI2600 camera. So we saw a bit more of the Rosetta Nebula tonight before it drifted down into the treetops. And we'll try this one more time. Oftentimes when we start up, we have to the tree. Oh, it's still being cantankerous here. Got a little bit of a glitch in Starry Night Pro plus Starry Night Pro as well. There we go. When we start observing, sometimes especially, it won't let us begin the first observing session. So let's one more time say we're using the 2600, and one more time associate it with the Caldwell list. All right. Now we are finally through, and we can say on the Caldwell working list, Al, glad you're here. Ernie, thanks for joining us from Buffalo. And Greg, hello to you from Las Vegas. Are you right in Las Vegas, Greg? Because I bet you have a lot of light pollution there. That's the city of lights, isn't it? We're going to add C49 to Caldwell Observed. By the way, I want to show you something very interesting. In Starry Night Pro, we noticed the other night, there is, if you click on these three lines here, you can say remove C49 from Caldwell Working, but it doesn't work. It doesn't remove it. All it does is remove the check mark, but it doesn't remove the object. So what we have to do is go up here to Live Sky and edit, because Live Sky is kind of a bridge between Starry Night Pro and Sky Safari, and then Simulation Curriculum provides this for us. We're going to search for C49, and there it is, and we're going to remove it from the working list. I'm just confirming that we're indeed in the working list, and we're going to save this. All right. So there you go. So we're using a process called live stacking here, and that lets us average out a lot more of the image than what we would otherwise see. We're going to switch now to what we might call our next target mode, and that changes the exposure and all. Now we're going to see if we can still catch, let's do an altitude sort here. Yeah, 14 degrees C10 is. Let's slew there and see if by chance we can catch C10 before it disappears in treetops. It looks like it's about 14 degrees above the horizon. So we're going to find out if we can still catch Caldwell 10. You can see the telescope moving around there. This is what you call Pier West. So the weights are up now a little bit on the east side, and the telescope is leaning over on the west side. If you look there in the telescope, the scope view, you can see a little thing. That's a little airplane coming into, I think that's runway 27 here at the SDF Louisville Airport. So you can kind of see where we are. Let's zoom in on our planetarium software. We might catch this before it goes down in those treetops, but we are really seriously in the Louisville Light Dome tonight. Here we'll do a plate solve, and that'll help us to match up the night sky with our mount and its expectations of what it thought we should be seeing, and we'll kind of join things together. And so what it's doing is it's looking through its kind of collection of images of the starry night, and it's comparing all these pinpoints of light in the images that it has on file with the pinpoints of light that it's seeing through the scope. And I don't know if you can tell here, we did line up a bit better with the image. It's 0.52 degrees off on this second slew of the night. And you can already see this cluster here in the middle of the frame. I don't even think that we'll have to do live stacking, really. We'll maybe do a little bit of live stacking, but we don't really have to do much to see this image. You can see a little bit of light pollution there in this part of the sky. But you know, it's not as bad as it really could have been, because we are using a light pollution filter. And we're using the Celestron light pollution filter that's made for the RASA 11. So you can see this is an open cluster, Caldwell 10. It's also known as NGC 663. So I'm going to change the title in SharpCap. Back in the old days, if we changed it while it was imaging, while it was live stacking, it used to not allow us to be able to do the changing. But now, thank you, Robin Glover, it has allowed us now, and we can now change that target name after we've begun live stacking. So this is Caldwell 10, otherwise known as NGC, put that in parentheses, NGC 663. And it's an open cluster, and it's in the northern sky. If you can just do a quick little color balance here and back off of our mids. We have them cranked up to be able to see all that faint nebulosity of the Rosetta Nebula. Now we don't have to crank them up quite as much. So here's this little open cluster here. We'll zoom in a little bit on that. And you know, it's a nice little open cluster. It's located 6,000 light years. 6,000 light years. We'll add that to the title here. 6,000 light years from the sun. And you can see that in this view, there are all different brightnesses of stars here. So we'll just put here that it's our first time to view this cluster, a brand new cluster for us. This is a nice open cluster of approximately, we're going to guess that there are about 50 or 60 stars there. Ernie, good to have you on here from Buffalo. I was curious how cold it was in Buffalo. We're down to about 45 degrees here in Louisville tonight, so not quite as warm as it was on Saturday. So what we're going to do now, that's Caldwell 10. We'll go ahead and add this to our observed list. And then we'll go over here to Live Sky. And once again, we'll edit this list. And we'll search for Caldwell 10. And we'll go ahead and remove that from the working list and save that. It would be handy if this neat little menu item worked here, so we could check that, and then it would remove it in Starry Night Pro Plus, but it's not working. Back to our image, you can see there's that open cluster. You can see it. It does have a lot of. This is a live view here on your left side. This is not something like a planetarium software, not something like a computer program. We're actually looking at this part of the sky, and if you look carefully at that part of the sky, you can actually see the Big Dipper. Let's see if I can get over there. You can see the Big Dipper right here, can't you? Are you seeing what I'm gesturing, or I don't know if you can see that. How do I annotate that? But there you can also see a nice big airplane flying across this part. In this image, you can also see the edge of the observatory and the roll-off roof there in the foreground, right in the line of the horizon of the trees. It's kind of an interesting view, isn't it? There's the RASA. It's a RASA 11 on top of an iOptron CEM70G mount, and that's on top of a Pier-Tech height adjustable pier. You can see we've got it dialed all the way up there at its highest point, and that lets us look at these objects really low on the horizon that we would normally never go image if we were doing astrophotography. Ernie says 39 and getting colder. Wow. If you show full field of view, it might be a couple of smaller clusters in the same field of view. You're right. I saw them when we were looking at this view. Let's see. Let's go back to full field. Right here's another cluster. And that would be what? NGC. Let's zoom in here. That's NGC. Is that 654? NGC 654. So thanks for calling our attention to that, Ernie. That's a good catch. I saw it in the Starry Night Pro view a moment ago, and we didn't look for it in the big view. So let's go to this info window and let's go back to our editing thing and say, Ernie also called our attention to a live view of NGC 654, another open cluster in the same field of view. Awesome. NGC 654. Let's look for that real quick. NGC 654. We'll go up here and do an observation of it too. Yeah. Saw this with Caldwell 10. Adds a nice flavor to the field of view. So that's NGC 654 over here. Wonder if we annotate these. Let's go to our deep sky annotation, if it'll. Yeah, it's off a little bit because of the way we did that last slew, and it's not quite matching up exactly. This is actually Caldwell 10, and over here it's Caldwell 654. It doesn't match up exactly right all the time, does it? Anyway, nice view there. All right, you're seeing the observatory. Thanks a lot, Ernie. Yeah, this is Caldwell Caldwell 10, NGC 663, and here is NGC 654 over here. So it makes a nice, neat little contrast view of a smaller cluster. I wonder how far away NGC 654 is. Let's go over here and see if, let's see if we can see the info for 654. 7,000 light years away. Small in size, but rich in stars. Usually high number of variable stars. Interesting. So that's 654 as well. Okay. Ernie, thanks for your help on that. All right, well, we're going to go back to our lists now and open up the Caldwell working again. And we've done about 7 minutes, so we'll go ahead and do a picture of a snapshot of this view. And let's sort by altitude again. Okay, so that's C10. It's vanished, hasn't it? Oh, I guess maybe because we already cleared it from the working list. So there you go. C14 is at 12 degrees. Let's stop our live stacking and let's see if we can catch C14. C14 is at 12 degrees above the horizon, and we'll center on that as well. You can see the number of Caldwell objects that we can observe from the north, the northern hemisphere during this time of the year is gradually, we're chipping away at it, aren't we? We're making progress on the ones that we can see this time of year. Now, in various seasons of the year, we would see other Caldwell objects, but we're beginning to make a dent in it. And the Caldwell list that we can see this time of year. You can see on our planetarium software here, we're going to actually be able to see not only this Caldwell 14, otherwise known as NGC 884, but we'll see another open cluster. So this is another case of seeing, let's open up this. Is this the double cluster? Let's open this up. Yes, this is the double cluster. So it's known for being 2 clusters in a row here. And looks like we observed this back in January of 2021. So that's been a year and 4 months ago. Double cluster, beautiful collection of stars. And then in February of this year, we observed it again. It said it was crystal clear on a clear night. So we're back again now in the Caldwell. We're only off 0.03 of a degree on this object. This is Caldwell 14. Let's start the live stacking on this now. And so start imaging. And when it does that, you notice, sometimes you notice that you get just a quick glance of the last picture. That's because SharpCap is actually saving the last picture in its memory. It has like a live RAM loaded view of its last picture. And when we do that clearing of the live stack, it clears out that image from the RAM and starts stacking anew. So you can see here the beginnings of our double cluster. Let's do another color balance here, and we'll move the darks in to the top of this new crest. We're over here in different kind of Louisville light pollution now. And you can see we're not zoomed in at all here. This is a pretty wide target, but you're seeing both clusters, 2 different clusters at once. And so we'll go to the description here. The famous double cluster in Perseus is one of the night sky's finest jewels. NGC 869, that's the one. Let's see, 869. Let me make sure. Let's zoom in on this a little bit more in our. Yeah, 869 will be the lower one. 869, and 884 would be the highest, are a pair of bright and large open clusters embedded in the faint glow of the Milky Way. The double cluster is visible without optical aid, but binoculars are required to separate the two clusters, which are a half a degree apart. A rich field telescope gives the best view of the double cluster, and that's what the RASA 11 would be classified as. Categorically, it would be a rich field telescope. Many different stars of differing brightness are visible. 869 is a more tightly packed. This is 869 down here, more tightly packed than 884. Both clusters are about 7,000 light years away and are part of the Perseus arm of the galaxy, one of the spiral arms of the Milky Way. The two clusters are a few hundred light years apart. So it's a fascinating view that God has given us here. We'll take a snapshot of this, and you can see with these clusters, they're a little easier, even in a light polluted sky, a little easier to see, and it's very low on the horizon. Right now, the position in the sky, you can see this is just, looking for the altitude, 11 degrees above the horizon. So even though it's only 11 degrees up, we can still see a pretty good view of it. So let's do this a beautiful view of the double cluster, even though it was only 11 degrees above the horizon. And I think our treetops on that end are around 10 degrees, so they're just barely coming in to view there. So again, this is, see, I didn't change this, did I? This title down here, C14. Sorry, that's kind of misleading, isn't it? C14, and we said that was, I guess the Caldwell object is both of the clusters at once. But in our title here, we should say NGC 884 and 869 together. 884 and 869, and this is the double cluster. Sorry, I forgot to change that title. So take one last view of the double cluster, and let's go over to our live sky here and edit this again, and we're going to look for C14. It was interesting when Sir Patrick Caldwell Moore, when he wrote out the Caldwell list, it's interesting, isn't it, that he chose this object as a double. Both clusters together are together called Caldwell 14. And I think that's because he recognized, well, that's the way they look in the telescope. So because he was an amateur astronomer, he would see these as one object, because in the way an amateur astronomer would view them, they are one view if you have the right telescope. Dennis, good to have you on board from Colorado. Welcome. We're trying to make our way here through the Caldwell list. We're trying to catch some of these objects before they descend over our treetops. We just covered C14. Now we're going to go to C11. So let's slew to C11, and we'll also center it in our planetarium software. And we'll open up the information pane. And this is the Bubble Nebula. Wow, I bet this is really low on the horizon. I'm hoping we can make this out. This is C11, the Bubble Nebula. C11, otherwise known as NGC 7635, the Bubble Nebula. Boy, it's a faint nebula, so I'm not optimistic here. Let's do a quick plate solve here. The reason I'm not optimistic is because this is sitting, look at the way the scope is oriented. It is looking just right across the roof of the observatory. And you can see that in this picture. It's aimed right across the roof. And it's looking way down in that light dome of the Louisville light pollution. So I'm not optimistic we'll be able to see this, but let's try it anyway. We were 73/100ths off, so that'll make sure that we get this right in the middle of the frame. Let's go over in our planetarium software and zoom in on this. At least, hopefully we'll be able to see this in our planetarium software. Look how low it is. So that's what we're trying to see, that faint nebulosity there. Let's go over here and let's start our live stacking. And Bubble Nebula is NGC 7635, Caldwell 11. It's an emission nebula in Cassiopeia located 12,000 light years from the sun. It's a large and extremely faint nebula, a serious challenge for visual observers. It requires an extremely dark sky, and in parentheses, we should put here, not the light dome of Louisville, Kentucky. To observe it with an eyepiece, you have to use averted vision. What that means is you're looking somewhere else, and you're trying to see it out of the peripheral vision, because the way God made our eyes, when we look at it right in the middle, our optic nerve is back in there, and we lose a little bit of our night vision when we look at it right straight on. So we look a little bit off to the side and try to concentrate on our peripheral vision when we're using an eyepiece. And sometimes we can see a little better with that averted vision. It requires an extremely dark sky, averted vision, and a narrow band nebula filter. We do have a filter that's like that. It's kind of like a narrow band filter. It's a light pollution filter, but it kind of is similar. So we'll do another light. We're trying to match those crests up in the bottom here of the histogram. You can see we have red and green and blue, and then a luminous filter. And what we try to do is automatically, if SharpCap can manage it, we try to line those up. So let's bring our darks back here at the crest. We're going to cheat just a little bit over to the left. The sky won't be quite as dark. And now let's bring our mids back and just see if we're seeing any of the Bubble Nebula yet. You know, this is a very nebulous part of the sky anyway. There are just lots of clouds in this part of the sky, and I'm afraid that that red patch that we see there is part of the trees. Let's see what this little cluster is here. See that little cluster off to the left? I don't know if you can make that out. Lots of little faint stars. Ah, it's, oh, that's M52, Messier 52, in the same image. And the Bubble Nebula should be right here in the middle, but it's so faint. I don't know if we're going to be able to see it. Let's try the sky a little bit darker. And move the mids in. For a minute, let's just move the mids in close again. This is just 2 minutes, so I don't know who we're fooling. But you know what? We are already seeing a little bit of the nebula right here. Let's go ahead and zoom in. I'm going to zoom into 100%. I'll show you what I mean. See that little bit of the nebula starting to form up there where that star is? Just a little bit of a cloud there, huh? So that's kind of fascinating that we're already seeing that. These are treetops we're seeing. This is M52 down here. Papa Tech, good to have you on board from Florida. We're at 45 degrees here in Louisville, Papa Tech. I bet you're at, typically you'd be at 65. Good to have you aboard. Welcome. We're kind of waiting with our bated breath, Papa Tech, so that we can be envious of your temperatures down there in Florida. Of course, you're like chasing alligators around your yard and all. Oh my goodness, is it really 70 degrees? That is so not fair. Could you like catch a little bit of that in an envelope and just seal it and just mail it up to us, please. 45. That's just unreal how much difference that is between just a few miles. Papa Tech responds, you asked. All right, so let's zoom in a little more here now. And what we're going to do is, and I don't think it'll do it. I don't think it'll help us to know the color balance, because I think we're about as color balanced. Oh, I think I saw the beginnings of the bubble. Let's see if we can make the night sky a little bit lighter. Maybe that'll help us see a little bit more of this nebula. No, it's getting mixed in with all the light pollution, isn't it? Let's bring it back. 59 in Colorado, but going down to the mid-30s tonight. Yikes. That's like cold enough to go out snowshoeing or something. Tell you what, we're going to cheat a minute and bring these mids up. See if we can force. Now we're starting to see a little bit more of that nebula. Let's go back over to our planetarium software and zoom in a little bit more. So this is what we would see if we imaged for about 6 hours. That's just a beautiful picture. Look at that bubble there. Looks like we observed this in 2020. In fact, this was one of the first objects that we ever looked at, and the picture that we made that night is really green. I wonder if I can find that picture. Let's see, what would it be called? It'd probably be called I think it was an LBN. We used LBN 548. So we're going to actually look for this. I'll look for it down. I'll pull this down here off screen so I won't bother you while I look for it. This is one of the first pictures we ever took. LBN 548. I think that's the, yep. LBN. That is not the one I thought. Surely we didn't call this NGC 7635. It also has an IC number. I thought it was interesting to compare, since it was one of the first pictures, one of the first snapshots we ever made. It is so bad, so ugly, but nevertheless, it is interesting. We were just clueless. It was like starting out, you know. You know how when you're starting out, you're even crazier than we are now. LBN 918, that's not it. No. What was that date? 1226? Maybe it's way back in the old. Oh, look, I can hover over those. No, I'm not going to be able to find it. I'd kind of like to find it so we can kind of poke fun at it, but I'll have to find that and show it to you another night because it is dreadful. No, that's not it. That's one of our early pictures of the, that's dreadful too. You know, we were just starting out anyway. Anyway, that was 1226. Beautiful bubble, starry nights. Description said it required super dark skies, even with the moon out in the same quadrant. RASA still pulled it out. Yeah, I was kind of fooling myself. And then on September 10th, I said, peculiar bubble. Tonight, boy, we're going to need some more minutes. This is 8 minutes so far, but in this light pollution, I don't know. I think we're going to need more minutes to pull it out. I'll tell you what, while that's stacking, why don't we go see what the Hubble did with this, because that'll start to help us a little bit. 43 and rainy in Bordeaux, Quebec. Thanks for sharing your sky. At the end, we're glad to have you here, man. Ernie, you got to call it a night. It is late there for you. Your Eastern time. Thanks so much for stopping by, Ernie. Good to have you. Well, we'll keep trying to live stack the light pollution there. And while that's live stacking, let's go look at what the Hubble found. So this is C11. Yeah, it's going to look pretty spectacular, isn't it? What do you expect from the Hubble? Oh my goodness. You know what you could call this picture? Since we know the origin of this, we can call this the Hubble bubble. This is the Hubble bubble. Look at this. This is Caldwell 11 Hubble style. Oh my goodness, look at that. Doesn't that just look like something that your 5-year-old went out in the front yard with one of those huge bubble making deals and soaked it in the huge tray and then ran through the front yard making this huge bubble, and it just wobbled around and finally separated from that wand, and now it's floating around in the front yard, and here is our snapshot of it. And then we kind of colored it up some in Photoshop and told everybody it was the Hubble Space Telescope image. Here's the star that's probably making this. This incredible image shows a bubble floating serenely against a muddy celestial background, forming object number 11 in the Caldwell Catalogue, more popularly known as the Bubble Nebula. And now we've christened this picture the Hubble bubble. Caldwell 11 is an emission nebula, a cloud of gas that gives off its own light and actually includes not just the bubble, but all the gas surrounding it as well. Well, if that's the case, then we're going to count this as seeing the Bubble Nebula, because you see, we have a little bit of the gas. Trying to just make it dark enough to see. The part of the gas we have is right there. And if you look over the planetarium software, you can see, hello, planetarium software. Hello. Come back to us, please. There we go. You can see this brighter part of the nebula here that this star is lighting up. And the bubble is not the only thing. It's actually pretty dim down here in the lower quadrant of the bubble. The top part of the bubble is easier to see. So we're going to count this as having seen the Bubble Nebula, even though it is a very, hey, you know what? This is the beginning of the bubble right here. See that round arc? After just 11 minutes, it is starting to come out, even in the light pollution. Make the sky a little darker. Not that dark. I'm going to hold the shift key down. That'll help me. You know what I think I'll do here? Let's do another color balance. Oh yeah, look at that. We're going to dial the blues down a bit and dial the reds up. Aha! Look at that. Woohoo! So in a distorted kind of way, now we're starting to see the bubble. Look at, we can see this entire arc here now. The entire part of the bubble that is over here on the planetarium software. We can see this entire arc of the bubble here. Look at that. And then this part over here is this part here in the planetarium software. So again, on the right, this is your photo book, you know, your map of the night sky, the planetarium software. And then on the left, here is the bubble. Dennis Luttrell, might as well stay up the rest of the night, Papa Tech. Papa laughed out loud at that. We are going to count this, man. So I'm going to do a snapshot of this, save exactly as seen. Not our best picture of the Bubble Nebula, but it's enough that we're going to call it a night. It's just at 10 degrees anyway. So what do we expect through all that atmosphere, right? we'll come back to this another day. I'm going to stay here on our observation. Was not, I better get my keyboard in the right, was not our best view of the Bubble Nebula, but we could make out the entire arc, even though we were observing at just 10 degrees above the horizon. That's crazy. No astrophotographer would try that. Amazing bubble. You know, you have to ask yourself, what causes that bubble, right? And I believe it's an ejection of material. See, we already put C14 in the, no, we didn't. And now C11. Add that to the observed list. And then over here in live sky, we'll edit and look for C11, and we'll remove that from the working list that we have. Now I wonder if they explain what Caldwell 11's bubble can be thought of as a continuously receding shock wave emanating from that star, which is positioned in the upper left of the bubble. The star's stellar wind reaches 4 million miles per hour, carrying particles from the star's surface and helping to propel the shock wave outward. The result ends up looking like a planetary nebula in which a star's outer layers expand outward, but is in fact gas and dust from the surrounding nebula that's being pushed away from the star. The surrounding material is more dense to one side of the star, so the stellar wind meets greater resistance and progresses less in that direction, offsetting the central star than the geometric center of the bubble. So look here, we can see this clearly in this view on the right here. Tycho 4279-1582-1 is the star that's emanating this bubble, but because of all this extra gas here, it meets with additional resistance and it travels faster as it travels out in this direction. That's fascinating. Discovered by William Herschel, November 1787. All right, let's do another altitude sort here. And let's go to C13. Do we stop our live stack? Yes, we did. Yes, so we're going to go to C13 now. And we'll open up the info and we'll also center on that. C13 is the Owl cluster, otherwise known as the Dragonfly cluster, otherwise known as the Kachinadal cluster, otherwise known as the ET cluster. And it is an open cluster. So we're going to say C13, otherwise known as NGC 457, and otherwise known as the Owl cluster. Well, it's fitting that we would catch it right as it's starting to land in our treetops. The Owl cluster. We'll put it up here in the target name for SharpCap, because that's what SharpCap uses if we save the picture. That's what SharpCap uses. We're going to plate solve just to bring the cluster over to the middle. And when we do that, remember, we adjust the model that the mount is drawing of our night sky, and it makes up for any imperfections in anything. The slewing ability of the mount or polar alignment, which I think is pretty accurate because it's there in the observatory. You know, we're observing from this this observatory here that we call Emerald Hill Skies. You can see the telescope there peering out of that roll-off roof observatory, and that's a RASA 11. This, of course, is a snapshot from the daytime, but it does give you a little better view of the observatory. So Pier-Tech Tele-Station 2, you can see inside there, we have a little TV monitor now mounted on the wall that we use when we observe in the observatory when it's just a little bit warmer. And that's a Pier-Tech Adjustable-Height pier that's inside of there as well. So there we're looking down over one of the walls and seeing the scope. So Here's what the scope is seeing, and we're right in the treetops. So take a look real quick at the Caldwell 13, and we'll just take a snapshot before it disappears behind the trees. It is an open cluster that's really open. You can see an image of the shadow of this tree, and we'll go ahead and do just a bit of live stacking so we get rid of some of that light pollution. In the description, it basically just says that Caldwell 13 or NGC 457 is a rich open cluster composed of nearly 100 stars in the constellation Cassiopeia. Of interest is the ET-shaped asterisks in this cluster form. Well, now my curiosity is up. Is it really shaped like ET? It's a great object for beginners and star parties. Binoculars and small telescopes are recommended instruments. It lies 9,000 light years away. And there you see the limb. Oh, look. It does look like ET. Oh my goodness, that's fascinating. This is my first time to ever look at this cluster. So I would not have been able to think of this had it not identified it. But look, there's his forehead, and his head narrows here into its thin neck, and then here's his chest where his heart was glowing, and he said, "E.T. phone home," is right here. Who knew? Okay, we're gonna start our log entry here, and we're gonna say, amazing. We could see the shape of ET in the cluster. Have any of you guys ever noticed this? Papa Tech or Dennis, Etienne. Any of you guys ever seen that the owl cluster actually looks like ET? It's amazing. I mean, I think it's amazing. We're going to add this to our observed list. Caldwell observed. This is Caldwell 13. We're going to go to Live Sky real quick, and we're going to edit and look for 13 and delete it from the working list. Save. And let's look at Hubble's version of ET phone home. Caldwell 13. Oh, they don't have it. I wonder, sometimes they just don't have the snapshot. I wonder if I say NASA Hubble C13. Is that C13? No, that's not. I don't think the Hubble has shot this. So we've shot a galaxy that even the Hubble hasn't. How about that? As far as we can tell, anyway. Wow. We're doing pioneer work here of ET. That's just beautiful. Let's save this. Where is Drew Barrymore? First time for Etienne as well. Drew Barrymore is the little girl, and she's the one that always provided the comic relief in the movie E.T. if you haven't watched it lately. That's amazing. All right, we're off. We're going to switch back to live view here now. And if you notice, I'm a little bit hurried because these things are sinking. They're sinking down the horizon. C74 is just 7 degrees above the horizon. Hurry! Slew to C74. Center on C74. Oh, this is the 8-burst nebula. We've never looked at this either. It's a planetary nebula. Wow. That does not look very promising. C74. Oh, we might see a few stars here. C74. This is NGC 3132. The NGC stands for New General Catalog. 3132. And it's also known as the 8-burst nebula planetary. Okay, let's go back here to our screen and do a quick plate solve. C74. It's going to be very tiny in our RASA. Look how tiny it is. Just looks like an exploded star. Oh, no wonder it is an exploded star. NGC 3132 is a planetary nebula in Vela, about 2,000 light years distant. This is known as the 8-burst nebula or the Southern Ring Nebula. How about that? Let's look at our SkyCam. Fascinating. So we are looking in the southern. Let's look at our, kind of zoom out a little bit of our planetarium software till we see a cardinal point somewhere. Yeah, that's the southern meridian. So we're a little bit west. It's like south-southwest. And you can see in our planetarium software, oh, no solution found. Oh, I wonder why. Maybe we're not able to get low enough for it. Maybe we're not seeing enough stars. Let's dial up our gain. Well, we're already on 400. Let's just dial up to 4 seconds for a second and try to get a few more stars in the picture. And do one more plate solve. But you see here in our planetarium software, it thinks we're already below the tree line. But honestly, I don't trust our photorealistic picture of the night sky all the time because, you know, it's very hard to get it so exact. Get the tree line exactly where it is. Yeah, I don't think it's going to find it. Okay, let's just look around visibly in our screen here, and let's compare it to our planetarium software view. Hello, Starry Night Pro, come back to me. There we go. Let's get rid of that photorealistic horizon for a second. And let's look at the same rectangle we're seeing here. And for instance, let's look for these two. I wonder if I'm not seeing it. Here are two. See this little arc here? It's like a little corona. Not the virus, but a little. No, we're not close enough here. Can I just do this for a second? Which way are we oriented? Let's look at our scope for a second. Okay. Trying to just touch us into. Wonder why it didn't plate solve. Let's go back to C74 and issue the slew command again. Everything looks good there. We have one cable, water falling off the back of the scope. You can see that one cable. That's because we don't pass our data through the mount, since it doesn't work to do that with my mount. So I have one cable. I was just looking to see if that cable was snagged, and it's not. The cable's great. So that's not it. Okay, it's slewed again. Now let's try to plate solve again. Try to get us right on this planetary nebula. There are stars there, but maybe there just aren't enough to plate solve. I don't know how many it needs. I mean, does it need 15 stars, you think, to plate solve? I mean, if I'm counting 15 there. Maybe it's so far south and maybe I didn't download the, oh, no solution. I go up here to File, Settings, and look under plate solving. We're using ASTAP. Let's change to Astro Tortilla. That sounds more like a Mexican restaurant. But let's try to plate solve using Astro Tortilla. Astro Tortilla is a different set of plates, a different set of images. Oh. And maybe the ASTAP file isn't complete enough of the southern sky or something. Because if you stop and think about it, if Sir Patrick Caldwell Moore, where's my book? If Sir Patrick Caldwell Moore, if he numbered these starting in the northern hemisphere and went around to the south, oh, it found it. So Astro Tortilla gave us a better result than ASTAP. Now we'll get lined up. We were almost a degree off. Yes. Sir Patrick Caldwell Moore, he numbered these starting in the from the northernmost object, and he numbered them in order, unlike the Messier list, to the southernmost object. And that means 74. We're way down there in the southern hemisphere trying to see this object. And so for some, oh, I think I see it. It's in the middle now. All right, so we're going to zoom in. And we're also going to start live stacking now. How about that? Yes. Well, now see, sometimes we just have to be more determined, don't we? It just shows that you can't just, give up at first glance. When this frame pops into view, I'm hoping that Caldwell 74 will be, bam, right there in the middle. Ready? It's not. Let's zoom out a little bit. Well, maybe it is, and we just don't have it tuned because there's that corona now of stars. So it should be, oh, let's do a color balance again, and let's move our darks over. There it is. How about that? Right in the center. Now let's zoom in a little more. What an interesting planetary nebula. Look at that. Even at 60 seconds, we can already make out the reds. I'm gonna mess with this a little bit. See that little star in the middle? That's the white dwarf that's lighting up the planetary nebula. We can see the white dwarf in this planetary nebula better than some of the planetary nebulae that we've looked at, can't we? Look, he looks like, you know what? This is 100%. This shows how tiny this planetary nebula is. But I'm going to go ahead and zoom in past the optical zoom and let you look at a little bit of the digital zoom. Looks like a little eyeball. It does look like the Southern Ring Nebula, doesn't it? Wow, that's really cool. Now it is tiny. Let's see what size this is. Sometimes it's 1 minute of arc. Okay, so let's think about this. The sky is divided into 180 degrees, the part that we can see at any one time. So half the sky is 180 degrees. Each degree is divided into 60 minutes. And this is just one of those slivers. So this is 1/60th of a degree, if you want to know how tiny this thing is. Wow. You know, the picture that we're given in Starry Night Pro is not a great picture, is it? It's just like a little white blob in Starry Night Pro, even in the Plus version. No offense, simulation curriculum, but this picture bites. That is not a great picture. Can you believe if we got this good of a picture after 100 seconds in our 11-inch RASA, could we not have gotten a little bit better picture than this in Starry Night Pro Plus? Sorry, no offense. Over there on the right-hand side, that picture doesn't get any better than that because that's our map of the night sky. But over here on the left, this picture will continue to get better and better as we live stack. That's just 2 minutes of live stacking. And we already see a really cool image of an eyeball. Doesn't it look like an eyeball? You guys remember how the planetary nebulae form? Remember, you got a star like what? Is it like the red dwarfs? I mean, the red giants, I'm sorry. Isn't it like the red giants? And they swell up and swell up, don't they? And then they eject off their outer layers. And those get like jettisoned off into the night sky. And since they're going 360 degrees in all directions, it makes another one of these bubbles. And then what's left collapses down into kind of a reaction to that. It lost all that outer material. Now what's left collapses down and makes a white dwarf and reignites and starts lighting up like a neon sign the rest of the planetary nebula that ejected out. And what we're seeing here is the backlighting of all that ionized hydrogen material after just 120 seconds. So let's save this exactly seen. Looks like we're losing a few frames, and I'm sure that's because we're getting down into the treetops. Let's go back to the live view. And, you know, we caught it just in time. As we lose it into the treetops and all, we're going to say here, this is our first time to image C74. So we're going to say, wow. Well, first, let's say this. Before we go very far, let's remember here, I'm going to say funny that ASTAP couldn't plate solve this part of the night sky. So we tried Astro Tortilla, which is a different database of images for plate solving, and it worked like a charm. C74 showed up on the first frame of 20 seconds exposure. Even though this object was just 1 minute of arc, we could still clearly see the white dwarf in the middle. Fascinating stuff. C74. All right. Just got a call from my pillow, so good night, everyone. Clear skies, Dennis Luttrell. Dennis, thanks for stopping by. Let's add C74 to the observed list. Caldwell observed. Let's go pull it off of the working list. So this is C74. Save it. Now let's come back. You can still see it there. These are 3-second images. Let's zoom in on that. Even though it's 3-second images in the light pollution, you can still make it out. That's amazing. keep in mind how far our scope is. Just looking barely over the roof. In fact, it's at 6 degrees above the horizon now. That's unbelievable. Okay, C77 is at 70 degrees. I doubt we'll be able to see this, but let's try it. C77 is a galaxy. Spiral galaxy. It's also known as NGC 5128. So this is C77. So that's also in the night sky. You can tell by the number NGC 5128. A spiral galaxy. And let's go back to our, wow, look how beautiful it is in the planetarium software anyway. Wow, what a unique object. No fair, I wish we could see it. C77, it looks like, oh, we're still slewing. Well, that gives me a little more hope then. Okay, we're still plate solving in Astro Tortilla, but let's try it. Look how beautiful this galaxy is. That looks like the Pepsi galaxy. I'm looking over there at our planetarium software. This looks like the Pepsi logo, doesn't it? Thank you to the folks who are on the live stream. If you wouldn't mind, kind of let us know where you're observing from. The 10 of you that have joined us live, kind of check in, and if you don't mind, tell us the city where you are. I think Astro Tortilla is typically slower than ASTAP, but at least it did find it. And we were 1.15 degrees off. That's because we did a meridian flip. Look how the telescope flipped over. Now we're Pier West with the weights on the east side. So you can see in our screen view, I don't know if you can see that or not, but we're actually looking at the stars sliding across the frame as we readjust. Okay, so this is C77, and we're looking way, way, way south. The camera is set up so it can look over the top of the scope when it's viewing the North Star. So that's looking in the southeast portion of the sky. Wayne, welcome from wild, wonderful Chester, West Virginia. It is great to have you back, Wayne. It's been a while. Let's start our live stacking. We're trying to look at C77 here, and we think about in the planetarium software that it kind of looks like the Pepsi logo. I don't have a Pepsi here to show you. What kind of spiral galaxy is this, man? You can't really see the spirals, can you? Uh-oh. Is it not live stacking? Oh, no, it is. Okay, so we're going to do a new color balance, a white balance of this part of the sky. And we're going to scoot our blacks over at that crest. And then bring our mids up a little bit. And right there it is. Woohoo! What a unique galaxy. Look at that bar across the middle. Is that like the... We're going to have to read about this to figure out what happened to that bar. NGC 5128 is part of the Centaurus group, which also includes M83 and several other galaxies. It is a large galaxy, half a degree in diameter, easily visible in binoculars, and as a faint glow. A small telescope reveals the most prominent dark lane of any galaxy visible in amateur telescopes. The dark lane splits this galaxy's bright circular halo into two conspicuous halves. NGC 5128 is a cross between, I was going to say, cross between an elliptical and a spiral galaxy, which may have formed by a collision between a large elliptical and a smaller spiral. Centaurus A is a very strong source of radio emission and likely contains a billion solar mass black holes. No, I mean, sub-zero. A billion solar mass black hole at its core. Wow, that's a big black hole. A billion suns mass. A black hole equivalent to a billion suns. That's crazy. I'm trying to get my arm around that. A billion suns. Okay, let's tune this up and see if we can make this a little bit neater looking here. Get our blacks in order. I am really excited about this galaxy, folks. This is crazy. It almost looks like it's an alien galaxy or something. Oh, look at the way we're starting to see material across the middle of that black arm. And this is just at 5 degrees. I'm going to snap a picture of this before we lose it. 2 minutes and 40 seconds. This is one of the most unique galaxies I've ever seen. Look at the way it has that shape of an elliptical galaxy. And an elliptical galaxy basically has just a globular shape. But it's not a globular cluster. It's elliptical in its shape, but it's a galaxy still. At the end, it is not prudent to wrap your head around a black hole. That's awesome. But look how the spiral, what we're seeing is basically a bunch of the soot and dust that the spiral arms threw off like centripetal force, and the dust is so thick that we can't see through it, and it's blocking our view of the ellipse of this elliptical galaxy. You know what else you could call this? You could say this is the southern hamburger, because that black stripe across the middle looks like a hamburger, and then these are the two buns. So once again, our view on the left side is live. It's an actual, view through this telescope right now, this very minute. And look how it's only at 5 degrees above the horizon, but we're able to see this crazy galaxy at 5 degrees. For just a minute, if you'll forgive me, I'm going to use the digital zoom. And I'm going to zoom in just to see if we can make out any more structure using the digital zoom. And this is all just, we're losing our pixels here, obviously. But it is an interesting bit of structure, isn't it? But we're also losing our sky, I bet. This is just 4 minutes of data, and here are the trees starting to encroach. Save this one more time. Pretty amazing. Can you add cheese, Wayne says. Green Cat, Manchester, UK, just finished 1,350 subframes, 15 seconds each, with a 16 millimeter CCTV lens on an ASI-178MC on tripod for a wide field time lapse. Of what object? Tell us what you were imaging, pray tell, Green Cat. What a combination of a 16 millimeter CCTV lens, and the ASI-178 is this view, except we have the monochrome version and you have the color version of this same camera. By the way, that's a beautiful view of some of the Louisville light pollution over the top of those treetops in our southeastern, I think. Let's go over here on our, whoops, didn't mean for it to do that. Let's zoom back out again and look at where we are. There's the southern meridian. So we're just east of the southern meridian. So we're south-southeast here in this picture. And if we were to bring the photo horizon back into view, that's where we are above those treetops. Oh, let me get you back to them. That's where we are above those treetops. So right there is C77. We're just drifting down into the treetops. Let's save it one more time with 6 minutes of integration. And it thinks that C74 is no longer worth visualizing. Let me do a log entry here. Wow, so fascinating. Oh, that's crazy. Wow, so fascinating. After just 2 minutes, we could clearly make out the hamburger dust lane across what was clearly an elliptical galaxy merged with a spiral galaxy. And you can't see the spiral at all, though what's telling us it's a spiral is the dust lane. C77, thank you much for this beautiful view. All right, let's do a, oh wait, we need to add this to the observed list. Let's take it off of the working list. 77. Deleting it from there, and then save, and then cancel. Back to our one more view. I think we're just losing it now because of the treetops. Well, still seeing, looks like a flying saucer now. This is the southern hamburger. Look at those treetops. We're looking at it through the trees. That's fascinating what live stacking will do. And it's still accurately stacking frames. We haven't lost one frame, even though we were looking through the treetops. I gotta say this one more time. That's one of the most unique galaxies I've ever seen. All right. Grandson told me yesterday that the astronomy class at school is not a science. Really? Huh. Are you sure he's not taking astrology? That would not be a science. All right, we're going to stop live stacking here, pull ourselves away from this thing, and go back to next target. And that was C77. So let's do an altitude sort here again. We did 11, didn't we? Yes, we saw 14, I think, and 77. What about 13? Yes, we did 13. What about 74? That's what we just did, isn't it, a while ago, right? Yes. That takes us down to 4 degrees above the horizon, C80. C80. Omega Centauri globular cluster. Can we see that? I've never seen Omega Centauri before. C80. Please tell me we can see. Oh my goodness, it's in the trees. Look at this. Oh my goodness, it thinks it's down there. Let's get rid of the horizon. And let's, oh, I bet it's in the treetops. It is. Could that be it right there? Wow. Let's hope this will plate solve, but I am not optimistic. Maybe, is that it? I hope it plate solves. I would love to see Omega Centauri. We don't have much time left. It's disappearing. It's 4 degrees above the horizon. It might be low for you. Curtis Horn. Maybe you want something with harder math. That's awesome. Yeah, it is low indeed. Curtis says, let it stack. Well, first we're just making sure that we have it centered. I do see something in the middle of the frame. We're using Astro Tortilla, Curtis, because ASTAP stopped stacking for us in the southern sky. And we didn't know why, but we just switched to Astro Tortilla and it worked. So you know how Astro Tortilla is a little bit slower, but it was at least working. Field 1 did not solve. I wonder, is that how big it should be? I wonder how big this is in arc minutes. 55 arc minutes. So it's going to be a half a degree. That very well could be it right there in the middle. I bet that's it. Curtis says, just let it stack. Yeah, it didn't stack. So we're just going to try to see if it can stack anyway. We're at, let's go ahead and switch it to the 20-second exposures. And let's see if we can grab this thing. This is the largest globular cluster, I think, in the night sky. The finest globular cluster in the night sky, first discovered by Edmund Halley in 1677. Omega Centauri is a blazing ball containing over 1 million stars in an area larger than the full moon in the angle of arc in the night sky. Wow, look at that. There it is. Omega Centauri, and you saw it. Oh my goodness, this is my first time to see this. That thing is huge. Now, this red information that you see over here, those are treetops. But look, I cannot believe we're seeing this. This is so cool. Wow, I just want to play some Star Wars music or something. Good night, Wayne. Thanks for being here with us. Oh my goodness, Curtis, look at that. Cut out a region of interest and stack. Can we do that? How would one do that in SharpCap? I've never done that before. Curtis, teach us. I wouldn't know how to do that. But I can tell you this much. This is only 58% of our frame. Here we are at 100%. This thing is amazing. Let's take a picture of that before we lose it because it's sunk below the treetops now. Curtis says, no problem. Oh my goodness. We caught this just as it was at 4 degrees above the horizon. Still, it was stupendous. It was a huge globular cluster. Amazing. C80. I've got the title wrong down there. Please forgive me. I forgot to change it when we started stacking this. I was in such a hurry because I was afraid we were going to lose it. And C80 was NGC 5139. NGC 5139. The Omega cluster. Omega Centauri cluster. Or I should say Omega Centauri, a globular cluster. Wow. Caldwell objects are the best, Curtis says. Mashed potato mountain, have to change over your resolution to a smaller scale for ROI function. Oh, region of interest. Well, then it's about the same as zooming in, isn't it? It's really about the same, roughly. Okay. Well, I'm fascinated by this, gang. This is an amazing night to be able to see Omega Centauri. Thank you, Lord, for letting us see Omega Centauri tonight as it sank on the horizon. Let's see, that was C80. Let's add that to the observed list for the first time in my entire life. And perhaps you're like me. Maybe this is the first time you've seen Omega Centauri as well. Some of you, not all of you, some of you have seen it. Oh, delete, delete. Caldwell working. Edit. 80. Remove. Delete. There we go. All right. What do we got left? C11, 77. 16. We didn't do that. This is an open cluster. It looks like we observed it one night. June 18th, 2021. And on that night we said, so many stars. Fun. Uh-oh. This is close to the horizon too. It's at 4 degrees. Wait, C16. Yeah, 4 degrees. Oh my goodness, there's a electric power line across our image. You know what? I'm going to go back here and change to ASTAP for live stacking for plate solving, because I think ASTAC is a little better when we're not in the southern sky. Omega Centauri, Mashed Potato Mountain says it's really cool to get Omega Centauri, I think, yeah. It is really fun, isn't it? And it was just right there on the horizon by the time we got there. Nope. No can do with ASTAP. Let's go back to Astro Tortilla. Try it. Thank you all for being with us tonight. It makes it a lot more fun, the fact that you're here. If you haven't yet checked in, if you haven't told us where you're observing from, go ahead and do that if you would. Jeff Horn. Hey guys, just checking in. Hope you all are well. Jeff, glad to have you here. I bet it's been a long day in the operating room for you. Bless your heart. Thanks for saying hi. You're awesome. I don't see how you do that. Oh my goodness, look at that photobombing of that, whatever that is, an airplane, I think. Did not solve. I don't think Astro Tortilla is having much luck either. Still trying to plate solve. Still trying to plate solve. Did not solve. It failed as well. It's because of that silly power line. Let's look here in our planetarium software. Oh, look, it's so low. Look how many stars are there. Okay, so let's look over here. Star here. That's the northern sky. There's Cassiopeia. Boy, it's a nice cluster, isn't it? It's filled with stars, so many. Let's do this. Let's try to look for one of these stars. Let's slew to this. See if we can get off of those power lines. This is going to be, if we can find it, this is C16. Didn't move much. Now let's try to play solve. We've given it a few more stars to find, a little better pattern. Mike, Jerry, welcome. John Kotko. What was your total exposure for C80? We saw it in the first 20-second frame, John. You could make it out. And boy, we didn't have much time. It was at 4 degrees. So I think the total exposure was maybe 4 minutes by the time it stopped stacking and was too low on the horizon, started to sink into the sunset. So it was easy to see it if we had just, been there even a minute or two earlier. But once again, Astro Tortilla is not looking promising here. I think these power lines throw it for a looper. But there is a pattern there. I think if I were a computer, I would find that. Let's change the title. It's C16. We're trying to find, we're on a treasure hunt for C16, which is an open cluster, NGC 7243. NGC, no luck, 7243, an open cluster. Rats. Well, let's just look. Here's a thing that looks like an L shape. Anybody see an L shape? Man, with this many stars, it's hard telling where that L shape is. L shape, 2 stars. Here's a little dish. Man. Let's try to slew to this star. Well, in this moment of searching for this C16, I'll just mention that we've changed our audio. We used to use a big mic that I was right in front of my mouth, and honestly, I just felt restricted by it because I couldn't like lean in and constantly, and it sounded okay, but what we've gone to now is the brand new DJI mic, they call it. I mean, it's named after Mike Cherry, I'm pretty sure. Pretty sure that's what it's named after. DJI mic. And it comes in this really cool little container here. See this little container? And the transmitter is right there in the container. And then the receiver is there. The transmitter goes over here. Here is a sample of the transmitter. And I'm using a little Shure lavalier with it. And I'm really enjoying it. You guys on a field trip. This is the receiver. Hello, hello, hello. Is that not fun? Hello, 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 hello. That's receiver. And I am really enjoying it. Oh my goodness, we played solved. Woohoo! So what we had to do is we had to get it off of those power lines. Oh, Master Mountain, God bless you so much for encouraging your brother. You're saying the audio is better. Hallelujah. Okay, so now we're gonna, with that, we're gonna switch to the longer exposures, and this is C16 a la power lines. So anyway, I love this because now I can get up and walk around. For example, while that's live stacking, let me just run a little study here. Let's finish live stacking. I'm gonna put you guys on the screen there, and let's do a field trip. Taking my phone with me. I'm gonna put my hat on and grab my coat, and you guys tell me when you lose connection. Okay, so now I'm walking out. I'm in the auditorium, the little atrium we have here for an atrium. Now, out the door. And I'm about 20 feet outside my, but we have to remember that at this level, I'm actually feet below in the atrium again, coming down the hall. Hello, 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 coming down the hall. Oh, rats. Well, we had to try that, didn't we? We just had to experiment with it, didn't we? Right? I mean, it was worth a try, wasn't it? Boy, look, we're losing the image, aren't we? We're into those power lines now. That's not good. Am I back? You guys hearing me again? Hello, hello. Oh, this will be tunable here. Let me do a quick. Thanks for letting me do that little. Hello. Thanks for letting me do that little survey. Yeah, I'm back, Mike. Got the mic back again, Mike. Okay, so, boy, this open cluster is being difficult for us, isn't it? So I guess that's just it. I mean, it's just all those stars there. I would consider this a very loose knit open cluster. It's just all those stars there. Let's read about it. Huh. C16. I'm going to go out to here and say C16 NGC 7243 wiki and see what they say about it. Oh, very, very little. 2,800 light years away, a few white and blue stars. Well, you know, Sir Patrick might have been reaching a little bit on this one. Don't you think? I mean, I like it, but it looks like a part just of the Milky Way. Okay, thanks, Curtis. Glad to be back. Yeah, it's not Bluetooth. It's 2.4 megahertz or something, I forget, you know, a regular wireless mic signal, but it'll go 200 meters if you're not going through a wall and you're completely flat in ideal conditions. But these are not those. So I was hoping it would work out in the observatory and I could keep talking to you guys while I walked out there, but no such luck. Anyway, this is it. I mean, I'm kind of underwhelmed here, but I hate to say that because everything that God makes in the night sky, you can see what I said last time, perhaps if you can read that tiny print. So many stars, I just said. But at the same time, actually, this open cluster is so open, it probably is underwhelming after having just viewed Omega Centauri. That was the wrong order. We should have come to C16 first. Still lots of stars, but I'm just saying that to be nice to Sir Patrick. C16 is now at 5 degrees. And we're going to say add to the Caldwell observed list. And we're also going to go to live sky, and we're going to edit and then look for C16 and remove it from the working list and save. Okay, what else we got here, gang? In our last 10 minutes, what can we hit? Let's find the list again and go to Caldwell Working. It's going to search through all of the Caldwell objects that are still yet to be observed. We just did that one. Oh my goodness, C83 is at 2 degrees. Can we see something 2 degrees above our horizon? It depends on which horizon, right? Did I stop live cycling? I bet I didn't. Oh well, I'll stop now. 2 degrees. Looks like it's headed. It's pure west. There's the south meridian. Oh my goodness, it's right there on the south meridian. You know what? We might make that. So it's just barely looking over the top of those trees in that view. Just barely over the top of those trees. You can see the trees are just barely over the top of the observatory. Oops, look at these trees. Oh my goodness. What is this C83? What is it? It's a spiral galaxy. We're not going to make it, are we? Rats. C83. You know, he did these, remember, in numerical order from north to south. So you can tell something that's 83 is really low in the north sky, if at all. Mostly it's in the southern hemisphere, huh? So we're going to have to scout this out as to what time of the year is best to see it. And it is a spiral galaxy. So, right, I'm guessing behind that tree. Let's zoom in on the planetarium software. Oh, it's a nice looking spiral galaxy. We can just get to it someday. That's nice. Ooh. Look at that. Isn't that cool? Kind of reminds me of that whale galaxy thing we've seen before. You know, there's some bright stars here, but I don't think we can probably plate solve this, can we? There are only 3 stars visible. I don't see how it's going to plate solve. Let's change this to 4 seconds. There's no way that's going to plate solve. No way under the sun. Well, we're in our last 6 minutes. What else we got going on? We picked up the cover for the you know, in our observatory now, we have this screen right there. You can see it. See the TV screen, the computer monitor. I had a custom cover made for it out of Gore-Tex cloth, and we picked that up today. So that's pretty fun. I'm watching the live the plate solving to see if it solves. And now the scope cover is almost done. So I'm looking forward to getting that scope cover back in hand. Let's see. Told you about the new microphones. To help the audio in the mic in our see, how can I find it? Oh, it didn't plate solve. Let me see if I can do this. Can I do this? Yeah. I added some filters, something called Slick EQ in this chain, and then Reaper EQ, and then TDR Nova, Kotelnikov, Wider, and Expander. It's like, for instance, on Wider, as I'm talking here, listen to the way that this makes me narrower. So this is 0%. And then I'm going to 25%. This is 25% wider. And then I'm going now to 40%. And then I can go all the way out to 50 and 60% wider. I kind of like 40% myself, but you guys tell me what you think. Anyway, that's wider. And then an expander as well. And with all of these different filters, I think that helped the audio a great deal as well. So that was fun. Anyway, look, we can see some stars here. It's pretty fun, isn't it? But it failed to plate solve. So I have no idea which one of these solves, which one of these, but we could try like live stacking, couldn't we? Let's just try it. See if it'll plate solve. I mean, see if it'll live stack off those 3 stars that we have in the image. And then this will be our last image of the night. We've really made a dent in the Caldwell catalog. Let's go back over here to our right-hand side and look at our catalog. We just went to 63 and we did 83. There is nothing left. Oh my goodness, that looks like it's improved a little bit. There's nothing left to go see tonight of the Caldwell catalog, so we've made a huge dent in it. So this galaxy is the last remaining vestige, and it's hiding behind that tree. Pretty sure it's behind that tree. Yep, we'll have to try to catch this another night. So what does this tell us? Well, I think what this tells us is that in about 7 observing sessions, at the pace we were going anyway, we can make it through all of the Caldwell objects that we can see in the northern part of the sky. And let's take a look now. I'm gonna just look at the Caldwell objects as we close here. Let's take a look at the Caldwell objects that are remaining. So whatever it is, we've got about, I would say we've observed so far 40 of them. I don't know if we can go up here. Looks like 4 have not disappeared. Let's go under observing lists and let's go down and look at Caldwell working. Yeah, it says we've observed 39 of them, and that's if it's already synchronized. Let's close this for a second and go. Where is that? Is it sync with cloud now? I think that's it. And that forces it to synchronize in case it hadn't synced yet. So now we can go back to observing lists and look one more time Caldwell working out. 39 objects observed. So probably if we'd gotten this last one. So we ought to be able to do 40 for sure, and then 60 to go that we're going to have to wait on in other seasons. So I think we're ready for another catalog now. Next time, I was looking, for instance, at this tonight's best. And of course, there's always the Herschel list. There are 400 of those targets. So maybe that's what we'll do next, is the Herschel list. And then we'll keep track of the Caldwell catalog as we go throughout the seasons, and we'll pick up the ones that we can pick up in other parts of the seasons. And we'll also work with a couple of our New Zealand and Australian friends, and we'll get them to record sessions for us so we can pick up the remaining sessions from the southern part, the southern hemisphere, that we might not ever see in the north. So this does wrap up our 2 hours of observing for tonight. Thank you so much for being a part of this. If you like content like this and you haven't already done so, we wish you would subscribe. That gets us back up in the other heads-up displays of other searchers on YouTube. If you wouldn't mind saying, hitting that thumbs up button if you like content like this. And you could also click the bell if you like, and that way it would notify you when we're on live streams like this through your YouTube notifications. Thanks for being a part of this with us. Thank you guys for being here. Mike, it's always good to have you. Etienne, good to have you from Quebec. Curtis, thank you. Always nice to have you. Mashed Potato Mountain, John, and back we had Jeff. I don't know if you've already left, Jeff. Thanks so much. And for the rest of you that didn't, I see we have 14 that are still tuned in. Thank you all for being part of this. It sure makes it a lot more fun. Astronomy is now a team sport, thanks to you guys. Thanks to God for making all these cool objects amazing, Omega Centauri, that we could see that tonight. Hope you've enjoyed it. I sure am. And God bless. Have a good evening. Take care. And